Welcome back to today's deep dive. Imagine looking at just a plain metal box. It's about the size of a microwave. And then you realize it costs $12,000.
Right. I mean, that price tag alone tells you we are definitely not looking at your average consumer electronics here.
Exactly. We're looking at a product page from HDTV Supply today for the Kramer 3232S-XL. And our mission is to figure out exactly what this highly specialized device does, and why professional audio engineers rely on it so heavily.
Yeah, because if you're dropping the price of a used car on a single piece of gear, it really better do something incredible.
Okay, let's unpack this. And by the way, you can actually use the code 10% off at checkout, which is kind of hilarious for a $12,000 item.
Every little bit helps, right?
Okay.
But this is serious, fail-safe professional infrastructure we're talking about.
Right. And to justify that price, we need to decode the name. It's a mouthful. The Kramer 3232S-XL 32x32 analog balanced stereo audio matrix switcher.
Quite the title.
Yeah, but the 32x32 part basically means it acts like a hyperspeed 1920s telephone operator. It takes up to 32 distinct audio inputs, microphones, instruments, playback tracks, and flawlessly routes them to 32 different outputs simultaneously.
All using those little 5-pin terminal block connectors.
Exactly.
Well, what's fascinating here is the balanced stereo audio part of that name. It isn't just routing those signals, it's actively shielding them from interference.
Shielding them from what exactly? Like electrical noise?
Yeah, exactly. When you run audio cables across a massive stadium, they basically act like giant antennas. They pick up all this ambient electronic noise.
Oh, wow. I never really thought about them acting like antennas.
It's a massive problem in live sound. So a balanced connection actually duplicates the audio signal, flips the phase of the copy, and sends them both down the wire.
And then at the other end, it just flips it back?
You got it. It flips it back, and any noise picked up along the way gets instantly canceled out mathematically.
That is wild. So it guarantees a totally pristine signal over huge distances. That makes total sense for a giant concert. But what about the volume levels?
Right, the power behind it.
Yeah, because I see on the spec sheet, it handles a maximum source level of plus 24 dBu.
Which is massive, by the way. Basically, plus 24 dBu means this switcher can handle incredibly hot, loud audio signals.
Wait, like a screaming electric guitar amplifier?
Exactly like that. It handles it without the audio clipping or distorting at all. Plus, it has built-in input and output gain and attenuation.
So it's fixing the volume before it even goes anywhere.
Right. It internally adjusts the volume, balancing out quiet mics and blasting backing tracks before they ever hit the speakers.
Okay, but here's where I have to push back a little bit. We live in a world of digital audio networks.
Sure. Everything is digital now.
Right. Everything's Bluetooth, Wi-Fi, digital over Ethernet. So why on earth would a broadcast studio or a huge stadium spend 12 grand on a massive hardwired analog switchboard?
2 words for you. Zero latency.
Really, it all comes down to the delay.
Absolutely. When you're dealing with digital wireless, there is always a tiny delay as the signal is compressed, transmitted, and decoded.
Ah, I see.
And in a live broadcast or a massive arena, even a millisecond of delay can cause disastrous echoes or, venue-destroying feedback loops.
Yikes. Yeah, you definitely don't want that.
Not at all. Analog routing is literally the speed of electricity moving through copper. It's instantaneous and completely reliable.
Okay, that completely reframes it. You're really paying for absolute certainty, but practically, how do you manage 64 intersecting streams of analog audio fast enough?
Well, you aren't doing it by hand, that's for sure.
The whole box is just a 3-rack unit frame. It measures like 19 by 18.5 by 5.25 inches. It's tiny. You aren't standing there physically turning 64 knobs in real time during a live show.
No, definitely not.
Yeah.
If we connect this to the bigger picture, the answer is actually right there in the ports on the back.
Oh, you mean all those control ports?
Yeah. Yes, the audio is analog, but it's outfitted with Ethernet, RS-232, and RS-422 ports.
I always see those RS ports on spec sheets. What do they actually do in this context?
They are industrial communication standards. They allow a central digital control system, like a computer located thousands of feet away in a control booth, to send automated routing commands to the Kramer.
So the brain controlling it is digital, but the actual audio path stays pure analog.
Exactly. It remains pure, instantaneous analog. It's doing all the heavy lifting out of sight, reacting to that digital automation instantly.
So what does this all mean? It means the Kramer 3232S-XL isn't just a router, it's really the invisible backbone of high-end audio distribution.
Right. It's the foundation of the whole system.
It's the fail-safe, making sure the sound gets exactly where it needs to be, perfectly balanced and perfectly timed, without the audience ever knowing it's there.
Exactly. It's the silent partner making sure the biggest productions on Earth don't just fall apart.
Which leaves you with a final thought to ponder today. We surround ourselves with digital convenience, constantly upgrading to the newest wireless tech.
We definitely do.
But what does it say about the raw physical nature of sound that the absolute highest end, zero latency professional environments still demand heavy, hardwired analog copper? It seems that 1920s telephone operator isn't obsolete, they've just moved to the VIP backstage.